Welcome to Notes number 2 on solving systems of equations using the substitution method. Solving a system of equation means that you have more than one equation, not just the one equation with one variable, but now we've got two equations with two different variables, an x and a y. So previously you saw that you could graph them both. You can make a graph with putting your equation into y equals mx plus b form. You can take one equation, draw the line, take the other one, draw the line, and then where the two lines intersect will be your solution point. So that's always an option. However, graphing isn't always convenient. Maybe you don't have graph paper, you don't have your calculator with you. Or possibly the coefficients in the equation would make graphing really inconvenient. If the numbers are extremely large or very small, it's not always convenient to have a graphing solution. So what we're going to take a look at is the first algebraic solution that we can use to try to solve these equations. So here I have two equations, an x and y in each one, and I'm going to use what's called the substitution method. So the first thing I have to do, step one, is to isolate one of the variables. And to isolate the variable means you need to get it by itself. So what I'm going to do is I'm going to look at my two equations and I'm going to try to make a good decision about that. I want to try to pick a variable that maybe has a coefficient of 1, which will make it very easy to isolate. Otherwise you might end up with fractional coefficients, which is fine, but just makes it more complicated. So I look here, I see this one has a 3 as a coefficient, this has a -2 as a coefficient. Here, this one has 1. So what I'm going to do is I'm going to choose the second equation, and I'm going to solve this second equation for x. So here I have x plus 2y equals 9. In order to solve that, I'm going to subtract 2y from both sides. So I end up with x equals 9 minus 2y. Okay? Now that I've solved for x, I'm going to take this expression and substitute it in place of x in the other equation. So the other equation we have is 3x minus 2y equals 11. So I'm going to take this expression and substitute it in place of x everywhere I see it, because in the first equation, x is equal to 9 minus 2y. So I'm going to take that 9 minus 2y and substitute it in place of x in the other one. So I have 3 times, instead of x, I'm going to write down 9 minus 2y, close my parentheses, and then I write in the rest of my equation, minus 2y equals 11. Now that I've done that, I see that I have one equation and only one variable. There is only y in this equation. So this I can solve easily, just like you've done before. I'm going to distribute my 3 to both terms. And then once I distribute my 3, I'm going to have 27 minus 6y minus 2y equals 11. I'm going to combine like terms. So I'm going to get 27 minus 8y equals 11. I'm going to subtract 27 from both sides of my equation. I have negative 8y equals negative 16. I'm going to divide by negative 8, and I get y equals 2. So now I've found the value of y that works. Now that I have the value for y, I can go back and substitute y equals 2 into either equation. It doesn't matter which one. So I can go back to the top and I look at my two equations. It doesn't matter which one I use. I should get the same answer either way. I'm going to choose the second equation only because it's a little bit shorter. But again, it doesn't make any difference which one I choose. So I'm going to put in x plus 2y equals 9. So down here where I'm doing my work, x plus 2y equals 9. I'm going to substitute y equals 2 in place of y. So I'm going to have x plus 2 times 2 equals 9. X plus 4 equals 9. So when I subtract 4 from each side, I get x equals 5. And there's my solution. So you can either write your answer as a coordinate. I know my x value is 5, so I can write 5, comma 2. Or you can write it like this: x equals 5, y equals 2. Either one is acceptable. So now that you have your solution, to ensure that you've done it correctly, you should check both solutions into both equations, into the original form of the equation, not the equation that you modified. So I'm going to put 3x minus 2y equals 11. I'm going to substitute 5 in place of x and 2 in place of y. And then I'm going to evaluate this, so I get 15 minus 4 is equal to 11. And I see that 11 equals 11, so I know this one worked. In the other equation, I have to go back to the original form of the equation, not the one that I rewrote to solve for x. And I substitute 5 in place of x, 2 in place of y. So I get 5 plus 4 equals 9, so 9 equals 9. So I know I've done this correctly. If one of the equations doesn't work, then you know that there's an error somewhere and you want to go back and check. So let's try example number 2 together, and then you can try some of the other ones on your own. So step 1, I know I have to isolate one of the variables, and I look here, and this has a coefficient of 3, which is okay, but then when I divide everything by 3, I'm going to have a fractional coefficient in front of the y. Then the same thing here. Here, I don't want to divide by 2 in the second equation, because then I'm going to have here, y is going to have a fraction. So I see here that y has a coefficient of 1. So I'm going to choose to solve for y in the second equation. So to do that, I'm going to subtract 2x from both sides. So I'd have negative y equals 26 minus 2x. Now I have to divide both sides by negative 1, or you can multiply both sides by negative 1. It's equivalent. Make sure I do it to everything. So I get y equals negative 26 plus 2x, excuse me. Now that I've solved this for y, I'm going to take this expression, y is equal to this. So I'm going to take this expression and substitute it in place of y in the other equation. I used the second equation to solve for y. Now I'm going to take this, substitute it in place of y in the other equation. So now when I do this, I'm going to get 3x minus 2 times, and instead of y, I'm going to substitute that with negative 26 plus 2x. Equals 42. So now I have an equation with just x's. This I can solve. So in order to solve, first I'm going to distribute a negative 2 to both terms. So I'm going to get 3x plus 52 minus 4x equals 42. Then I'm going to combine like terms. I'm going to get negative x plus 52 equals 42. I'm going to subtract 52 from both sides. I'm going to get negative x equals negative 10. I don't want a negative x, I want a positive x, so I'm going to divide both sides by negative 1. And I'm going to get x equals 10. So now once I know that x is equal to 10, I can substitute that into either equation. It won't matter to find my value of y. Okay? So now I'm going to substitute it. It doesn't matter. I'm just going to choose the first equation. So it's 3x minus 2y equals 42. I'm going to substitute 10 in place of x, so I'm going to have 3 times 10 minus 2y equals 42. So I have 30 minus 2y equals 42. Subtract 30 from both sides. I'm going to get negative 2y equals 12. Divide both sides by negative 2. And I'm going to get y equals 6. Okay, so that's my solution. X is equal to 10, y is equal to 6. That's the coordinate they have in common. If I substitute 10 and 6 into both equations, it will make both of them true. So you can also write your solution like this. 10 comma 6, because x is your first value, x is equal to 10, y is equal to 6. So you can either write it as a coordinate, because if you graphed those two lines, they would intersect at the point 10, 6. Okay, so now I'd like you to press pause. I want you to try the examples that come next. And then once you've tried the examples, you can restart the video to check your answers. Okay, now that you've had a chance to try these problems, you can see that example number 1, the solution was negative 4 comma negative 8. Or you can write it as x equals negative 4, y equals negative 8. And I showed my work. You can press pause now and follow the steps. Number 2 was 2 comma negative 10, or x equals 2, y equals negative 10. Number 3 was 37 comma 40. Or you can write x equals 37, y equals 40. Number 4, the answer was not so pretty, but with a calculator, definitely doable. X is equal to 38/14, or the equivalent. And then y was negative 9/14. Now, like I said, this is not a very pleasant answer, but with a graphing calculator that does fractions for you, really not a big deal. Make any note of questions that you may have and bring them into class tomorrow. Thanks.